Okay. Question one. No. So hello everyone. My name is Abrar, and I'll be doing question one, three, and five respectively on our assembly codes. So for line one, essentially what the compiler is going to do is going to move the variable one, which is word one, into the register AX. So it's going to load it into the AX register. As for line two, there's it's going to be a step up, which means that variable 2 would be loaded into the BX. As for line 3, what essentially is going to do is that it's going to swap between the register AX and BX for their variables. So now AX is going to have the variable of 2 and BX is going to have a variable of 1. And for line 4, it's going to move the variable 1 into the AX register again. And also the same thing for line 5. And call DOMREG is supposed to show the memory of the register. So now I'm going to run the code. Okay. So this is the output, and I'm going to show you now the register memory. So this is our register memory for each and every one, as you can see right here. Okay, I'll add a question two.
Okay, moving on to question two and memory two. I'm gonna explain starting from question two, four, and six.
لحظة خد.
Okay, so going on with the question two, as you can see, line one, EAX gets 26 from memory. We are using 32-bit registers now. Moving on to line two, uh, EAX, the variable is equal to the variable. So NEG turns 26 into minus 26. This hex value is 2's complement form. Line 3, EBX first gets 30, then we subtract 40 from the result, minus 10. Line 5, we are adding minus 26 plus minus 10. It's equal minus 36. And finally, line 7, store final results into reval in memory. That's how you break down signed arithmetic in assembly. Now I'm going to show you the outputs and the registers. Okay, here's the output, and here is the registers.
Okay.
Okay, now moving on to question two.
So I'll be continuing on from question to question three. So in our first line, which is this, we're gonna load variable 5 into our EX. That's into our EX. The next line is that we're gonna multiply by 10 through. We're gonna multiply the register EX with variable 2, which is 10, and this would equal to 50. At line 3, it would essentially add the 20, which is here. We're going to add 20 to our register memory. So the output of this register, we're going to add it to the 20. And finally, for this line, we're going to decrement, which means that which is essentially we're going to decrement the memory of EAX, which is going to be 69 at the very end. At this line here, which is line 19, we're going to move variable 4 into the EX. So we're going to store the final result into variable 4. And DOMREX, as previously said, is just supposed to show the output as well as the register memory. So let me just debug. So as you can see right here, this is our output for our code. I'll show you just in a bit the memory of the registers. So right over here, you can see the memory of all of our registers. Okay, done.
Okay. So moving on to question 4, as you can see, in the first line we got the debug explanation for question 4. Okay. Before MUL AX, okay. Let's see. MUL gives the result in a AX since it's word size, you know. After sub BX equal the variable 007H, it's 10 minus 3 equals 7, and 200 divide 7 is equal to 29, the remainder 1 quotient. Quotient goes in EX, remainder in DX. Always 0 DX before the div to avoid garbage values. And then moving on to the debug and the memory register. Okay, so let's use the memories. Okay, thank you.
Okay. So hello, I'm gonna. This is question 5, which is we're gonna need to code our own assembly code in order to perform the set of calculations. Now, the reason why I use this, which is move dx0, is that it's going to clear out our dx in order to avoid overloading the register dx. Now onto here, we're going to move the value, the hexadecimal value of 1000 into our AX register. And in our CX register, we're gonna move the value of the hexadecimal value of 25H. And this line is gonna multiply the value of CX with the register AX. So it should, in theory, give us this value. Call number X, as previously said, is supposed to show us our output. Now I'm gonna run the code. So this is our output for our code. I'll also show you the memory for each register. So as you can see right here, this is our memory for each register in the code. Okay.
So hello, we're gonna now explain the last question of this lab, which is a question 6. Uh, in this code, we divide 2500 2051 by 16 using the BL register. First AX is set to the 0A 03H minus that uh, 2051. BL is set to 10H minus, which is 16. Then we use the div BL. The results AX becomes 0, 0 in the variable. That's 128, the quotient. DX is the variable, that's the remainder. So 2051 divided by 16 is equal 128. Remainder is a 3, and that's it. Simple division and assembly. Now we're gonna debug the code and show you the memory register. Here's the memory register. Okay, thank you for listening to our lab 2 and COA, and that's it for today. Thank you.